Yes, guys, so just let me check if I am live yet. Just let me check. Let's check. I can't see myself live right now. Let's check again as usual. So, I believe that I am live yet. Okay, so I am live. All right. I believe that I am live yet. So I am live. All right. I believe that I am live yet. So I am live. All right. I believe that I am live yet. Okay. Let me change the settings. Let me see. Change the settings. Okay. Do this. Okay. So just give me a moment to check. Um just let me see. Uh-huh. Yeah, now it's fine. Okay. Now I can continue, I believe. Is that showing now? Yeah, now it works. All right, guys. So there was some technical issue which occurred, and but now we have sorted that issue because some of you might know that I have changed my system. So that's why that little glitch came out. And so let's get started. Let's begin. As you guys know that this session is happening like very first session of January this is, and let's get started. As you guys know that this is Unacademy, and we are going to ace your exams with this. Okay, we are going to ace your term 2 examinations with Unacademy. Since you know that this category is quite new, no one is really very aware of the category, so help us to promote, to spread, to propagate. All right, now what we're gonna do, my brief introduction. My name is Kirti Sharma, and I am your chemistry educator. I have done my graduation through University of Delhi. So let me check if it's proper. Seems okay, seems all right. Yeah, so I have an amazing offer for you. I have a pretty big deal for you, and that is to kickstart your journey to crack it in 2022. And what is it? Guys, generally what happens is you get 10% off. Generally you get 10% off while applying the code when you get plus subscription. But it's like something huge for you, and it says that till 5th of January only. This session, this time period has been extended, this offer has been extended, and this is till 5th of January. So if you use my code, that is Kirti S Live. The code is Kirti S Live. If you use this code while getting the plus subscription, you are going to get 22% off. I would say additional 22% off while getting the plus subscription. All right, so it seems amazing, and go get the plus subscription right away. All right, that's the only thing I would tell you, that's the only suggestion I would give you right now. All right, so subscribe the channel, follow us, and get the plus subscription soon, because the plus classes have been started from yesterday, and those classes are going quite amazing. I want all of you, all of the ISC students, to be a part of plus classes as well, so that we can cover 100% syllabus, of term 2 examination. Okay, now, so what will we study today? That's the next part. What are we gonna study today? So you guys know that this is your chapter number what? This is your redox reaction. This is redox reaction lecture number 3. This is your lecture number 3. All right, for redox reaction. But before getting started with lecture number 3, I would like to give you a brief or a recap of lecture number 1 and lecture number 2 of redox reaction. Okay, so let's get started. That was your regarding your previous redox reaction. So it says, let's see, the very first thing that we did was the application of redox reaction, right? What was it? It was your applications of redox reaction. So we saw that whatever is happening around us, all the reaction, what happens is redox reaction, that is reduction and oxidation. As you can see here, that reduction and oxidation happens simultaneously. That's what we call as a redox reaction. So these are used in combustion, in your metallurgy, and in various other processes, as you can see here, right? Reduction combustion processes, this we have discussed. Electrochemical cells or batteries, we use them all the time, right? They are electrochemical cells. So what is happening inside that cell? Your chemical energy is getting converted into electrical energy via some redox reactions. So the type of reactions that are happening within the cell, those are what? Those are simply your redox reactions. Then even your natural processes such as photosynthesis, or you can say digestion within our body, these are also redox reactions. Apart from it, extraction of metals from either ores or minerals, we use metallurgy. In class 12, there will be a whole chapter of metallurgy, in which you will be discussing what are the various reactions which are happening, that are redox reactions, which are happening in the extraction of some particular metal. All right, so that what happens in redox reactions. Let's move further. Then we did that redox reaction, as I told you in the previous slide, that redox reaction is simply reduction oxidation reactions. What are these? These are simply your reduction oxidation reaction, or else what can you say? Oxidation reduction reactions. Okay, so that's why these are also termed as redox reactions. That's why these are also termed as redox reactions. So in case of all the redox reaction, what is the most common thing? The most common is that all in all redox reaction there is a transfer of electrons. There is a transfer of electrons, so it always happens. Then we discussed what oxidation is. You can define oxidation in three various manners, and I'll let you know the fourth one today. That is in terms of oxidation number. How can you say what is oxidation in terms of oxidation number? So oxidation, in the previous classes what we discussed, that oxidation can be simply addition of oxygen or any other electronegative element, or else removal of hydrogen, or else what can you say? It is the removal of hydrogen or any other electropositive element. And the third one that we saw was simply loss of electrons. What was it? It was simply loss of electrons. Okay, next we did reduction, which is like you can say quite opposite of your oxidation. So in case of oxidation we were adding oxygen, so in case of reduction we will remove oxygen. In case of oxidation, what was happening? There was a removal of hydrogen, but now we are adding hydrogen in case of reduction, or you can add any other electropositive element. And the third one is in case of oxidation, what was happening? There was a loss of electrons, but now in case of reduction, what is it? It is the gain of electrons. Reduction is simply your gain of electrons. So guys, remember this, that this is your gain of electrons. Okay, now let's move further. So the development of oxidation reduction reaction concept. So what can we see in this? That is reactions which are simply based on adding oxygen or removing oxygen, right? So these were the examples that we did. When you added oxygen to magnesium, MgO, magnesium oxide, is produced, and hence you say that magnesium is getting oxidized, right? If you add oxygen to carbon, we say that carbon is getting oxidized. Similarly, if you add oxygen to sulfur, we would say that sulfur is getting oxidized. So this is a very it was the like very basic and fundamental concept in the beginning. Like whenever you add oxygen, it becomes your oxidation. As simple as that. Next, we also discussed not just oxygen, not just when you add oxygen, if you add any other electronegative element as well. Apart from oxygen, if you add any other electronegative element as well, let's say fluorine, the most electronegative element in the periodic table, correct? So when you added magnesium to fluorine, magnesium fluoride was produced, है ना? Magnesium fluoride was produced, and you can say what? That this magnesium fluoride, in this case as well, we would say that magnesium is getting oxidized. Even now we will say what? That magnesium is getting oxidized. Although in the whole reaction, oxygen is not involved at all, but even then that's what we say. Then comes your magnesium plus chlorine gives you MgCl2. Again, you added an electronegative element, right? Similarly with sulfur, you added some electronegative element, that is sulfur to magnesium. So that's why we are saying in all of these three that the magnesium is getting oxidized here. Alright, so for oxidation to happen, it is not necessary that the oxygen should be present. Beta, I am discussing it in a very quick manner. The reason is that we have already covered these topics in our previous lectures. Okay, that's lecture number 1 and lecture number 2. Today will be our lecture number 3. Today will be our lecture number 3, and it will be regarding your oxidation number. It will be regarding oxidation number. Now, so reduction reaction is a reaction of releasing or losing of oxygen from an oxide compound. So as you can see here that copper oxide is getting converted into copper only. So that's why you are saying that there is a reduction. There is a removal of oxygen from copper oxide. So that's why you are saying that CuO is getting reduced. And similarly, in case of Fe2O3, it is getting converted into Fe. So that's why you are saying that here Fe2O3 is getting reduced to simply iron. That is your Fe, correct? So I believe that there is no doubt till now. Let me know in the chat section if you have any doubt, alright? And for further like such amazing lectures, subscribe to this channel, follow this channel, and you guys know that the code is Kirti S Live if you get the plus subscription. And one amazing offer is valid for today, and that is you will get 22% off today on plus. So this is like a kind of offer which is very rarely available. So avail it, and it is available till 5th of January only. Only till 5 Jan. This offer is valid. Then this will be discarded. Then this offer will be discarded. Okay. Now let's move further. So redox reactions based on losing or gaining of hydrogen, if we talk about. So whenever you convert either alkene to alkyne, as you can see here that this alkene is getting converted into alkane, right? From double bond, you jumped to single bond. So in that case, what do? You do reduction by adding what? Hydrogen. So this is the simplest example where you add hydrogen and you say that this is simply reduction. Okay, this is simply what? Your reduction. So I believe that there is no doubt till now. If you look at the last example, so what is happening? The reaction says H2S plus O2 gives you 2S plus 2H2O, right? That's what the reaction is. We have, okay. So what is happening here? See, H2S is getting converted into sulfur only. So there is a removal of hydrogen. What is happening? There is a removal of hydrogen. So that's why you are saying that when the hydrogen is getting removed, you always say that this is your oxidation, simply, correct? And here O2 is getting converted into H2O, water. So you added hydrogen, so this is your reduction. This became your reduction. Let's move on to the next one. We did some examples in which you guys told me where is oxidation happening, where is reduction happening. So that's what you told me. Okay. Now, redox reaction based on losing and gaining of electrons, a very important concept that we did in the previous lecture. So in order to convert a free element into an ion, what would happen? If you want to convert a free element into an ion, so what would happen? Then that particular atom would either gain electrons or it would lose electrons. These are the two possibilities, right? Depending upon the nature of that element, whether it is electropositive or electronegative, right? So of course, if one atom loses electrons, अगर एक atom ने electrons को lose कर दिया, if one atom loses electrons, another must accept them. So that's what happens in case of your redox reactions, right? Like if an element gains electrons, then the other would have been losing electrons so that the other one would accept them. Okay, so reactions where electrons are transferred from one atom to another are called as redox reactions. Atoms that lose electrons are being oxidized. As we discussed, that oxidation is simply your losing of electrons. So whenever an atom loses electrons, we say that this particular atom is getting oxidized, and the one who gains electrons, who accept electrons, you can also say the one which accept electrons, you say that this is that particular atom is getting reduced. All right, then we did these equations, we saw these. It was Na plus Cl2. There is some problem which is going on with my Wickham Cl2. Just give me a moment, and let me just change it. देख तूने एक सेकंड रुक, पहले म्यूट ही कर लेते हैं. Give me a moment, guys. There is some technical error. Let me get it sorted. I believe that it's quite sorted. Just give me a moment to, yeah, let me check if everything is okay in the class. Close the door, please. Okay, yeah. Where were we? We were discussing the redox reactions based on losing and gaining of electrons. So we dealt with particularly like the first, you can say the oxidation half and the reduction half of the reaction, correct? So that's what we did. this was your whole reaction. This was your whole reaction, which said Na plus Cl2 gives you NaCl, right? Na plus Cl2 gives you NaCl. So if you look at sodium only, so what are you gonna get? Sodium, as we know, is like a metal, electropositive, so it has a tendency to lose electrons, right? So it would be Na will be behaving as Na positive plus electron, ek electron it will lose, and this chlorine will accept the same electron because chlorine is electronegative in nature. He wants to accept the electrons. So half Cl2 will like accept one electron to give you chlorine minus Cl minus, right? So as in here, you can simply say that loss of electrons is wherever in the like half of the reaction, wherever the oxidation is happening, that is your loss of electrons. You say that this is your oxidation half, and wherever that electron is getting accepted, it is called your reduction half. And when you add both of them, it becomes what? It becomes the whole reaction. This is your whole reaction. This is your whole reaction. Okay. Now, let's see. It was another example. Simply 2Na plus half O2 gives you Na2O. So first you looked at the oxidation half and then reduction half. You guys know already that my username, my code is Kirti S Live, and today is a very big offer which is going on. I'm telling you guys again that you will get 22% off. That you will get 22% off if you get the plus subscription before 5th of January. This offer is valid only till tomorrow. This offer is valid only till tomorrow. Till 5th of January. Till 5 January this offer is valid. So use this code, that is simply Kirti's Live. Kirti S Live, as you can see it is written on the screen. Now then we started lecture number 2 with the beginning, and we discussed what is an oxidizing agent and what is a reducing agent, correct? So now we are gonna talk about oxidizing agent. So an oxidizing agent is the one which oxidizes others and gets reduced itself. That's why you call them oxidizing agent. The agent which oxidizes others, and if it is letting the others getting oxidized, then what would happen to that particular substance as well? It will get reduced, right? It will have a tendency, the oxidizing agent will have a tendency to such that वो किसी और एटम से, किसी और सब्सटेंस से एटम्स लूज करवाए. So an oxidizing agent will have a tendency to accept electrons, and similarly converse will be the reducing agent. Reducing agent is the one which reduces others and gets oxidized itself. So it is an agent. Reducing agent is the agent which help to get reduce others. But if like अगर उसके वजह से कोई और reduce हो रहा है, so reducing agent will get oxidized itself. Okay, so that's what it is. So oxidation and reduction must occur simultaneously. If an atom loses electrons, another atom must take them. The reactant that reduces an element in another reactant is called the reducing agent. That's what we discussed right now. The reducing agent contains the element that is oxidized. The reactant that oxidizes an element in another reactant is called oxidizing agent, and the oxidizing agent contains the element that is reduced. So it is simply what I made you understand. As simple as that, it is written here that oxidizing agent oxidizes others and gets reduced itself. A reducing agent reduces others and gets oxidized itself. Alright, then when we looked at what is a reducing agent and what is an oxidizing agent. So as we know that here, since sodium is getting oxidized, but it is which agent? It is the reducing agent. So if you look at the periodic table, at the right side of the periodic table, as you can see here, as in the right side of the periodic table, these are good oxidizing agents. These are good oxidizing agent. Why? Because they will have a tendency to oxidize other and gets reduced itself, right? In order to reduce, what do we need? We want to gain electrons. So all the, you can say, your halogens, oxygen family, nitrogen family, these behave as good oxidizing agent. Okay, then we did some important oxidizing agents. So any molecule which is made of electronegative element, that is your O2, O3 or any halogens, these will be what? Your good oxidizing agents. That's what we discussed, right? That's what we discussed, correct? Okay, so compounds containing element in highest oxidation state. In today's lecture, we're gonna see what do we mean by oxidation state or oxidation number. So KMnO4, K2Cr2O7, Na2Cr2O7, H2SO4, CrO3, these are the important oxidizing agents. Okay, now some more are, as you can see on the screen. Try to remember them. Important reducing agents, quite obvious, these will be metals, because metals want to lose electrons, that's why. So your sodium, zinc, iron, aluminium, etc. And a few non-metals also behave as reducing agents, such as carbon, hydrogen, sulfur, and accordingly some more things are given to you. And the one thing to remember is that lithium is the strongest reducing agent. I must have written it somewhere. Here it is. Lithium is the strongest reducing agent. Okay, and also cesium as well in absence of water. Okay, so substances that can behave as both oxidizing agent as well as reducing agent. So according to the need, right? If someone is like, according to the need, they can behave as either oxidizing agents or reducing agents. Okay, so H2O2, SO2, H2SO3, HNO3, Na2NO3, NaNO2, Na2SO3. So these are, or you can say O3, ozone. So they can behave as either oxidizing agent or reducing agent. Then we came across the oxidation number or oxidation state, right? Then we did what? Oxidation number or oxidation state, you can say. We discussed a little bit about this thing. Now let me give you just give me a moment. So here, okay, let's discuss it here as well. If I tell you some rules regarding the oxidation number, so we know already that oxidation is simply your loss of electrons and reduction is simply your gain of electrons. So this thing we know, right? So you can see here that oxidation numbers are a system that we can use to keep track of electron transfer. So that is the very basic need of oxidation, so that you can just keep track of the electrons exchanged or electrons transferred during a redox reaction. So let me give you some basic rules. So the very first rule which I would tell you is that for the elements which exist in free state, elements which exist in free state, in free elemental state, you can say, right? So what happens, such as what could be the examples? You can say like Cl2, it is its free elemental state. That's how chlorine is found in nature, right? In like naturally how it is found in term of Cl2. So in case of chlorine, Cl2, its oxidation number will be 0, or we can say O2, 0, or you can say nitrogen gas, 0, because these are the elemental state, these are the free states, these are the natural state how these are found. Or you can say sodium is simply found as Na, so its oxidation number here will be 0, right? Or you can say rubidium. If I say rubidium, it is found as simply rubidium, so its elemental state will be 0. Or if I say calcium, its elemental state will be, in the elemental state, its oxidation number will be 0. I'm not telling you this is the oxidation state wherever sodium is present, iska oxidation number or oxidation state will be 0. No, only if it is found as Na. Nothing, not like NaCl, simply Na. Only then its oxidation number is 0. Alright. Now, let's look at the next example. What we can say? So, if I tell you that there is an atom, and now it has become an ion, either by losing electrons or by gaining electrons. So whatever is the charge on that ion, in this case, what will be the oxidation number? Whatever is the charge on that ion. We did not discuss this concept in detail in the previous lecture, so that's why we are doing it right now. So charge on that ion, on the ion, will be its oxidation number. It will behave as its oxidation number. If I tell you, say Cl negative, if I tell you, say Cl negative, in this case, what will be its oxidation number? It will be -1. If I tell you, say Na positive, in this case, what will be the oxidation number? It will be +1. Simply the charge on that ion will become its oxidation number. Okay. Say if I tell you Mg2 positive, magnesium के ऊपर 2 charge, so its oxidation number will be +2, right? If I tell you that we have O2 negative, oxide ion, so that here oxidation number is -2. Okay, so that's what we can say, right? If it is, say, N3 negative, the oxidation number will be -3. If I tell you, what else can we take? If I tell you Al3 positive, the oxidation number will be +3. So simply the charge on that particular ion will be its oxidation number. Okay, I believe that there is no doubt till now. Let me check if there is any comment. Let me see if you guys have any doubt. Just let me know in the live chat if you guys have any doubt. I'm checking I don't see any doubts, so I believe that we can go ahead. So let's move further. Now, what can we say? If we talk about, you understood till now? If I tell you about, say, oxidation number of fluorine, if I tell you about oxidation number of fluorine. So as we know that fluorine is the most electronegative element which is present in the periodic table, right? So oxidation of fluorine is always -1. This is always -1. Wherever you see fluorine, this is fixed. So it is always -1 is always the oxidation number, or you can say oxidation state of fluorine. All right. Now, if we talk about, say, number 4, if we talk about oxidation number of oxygen, if we talk about oxidation number of oxygen, these are the, like, I'm telling you the rules, I'm explaining you the rules in a very simple manner so that you won't get confused. The slide which we used in the previous lecture was quite complicated. Someone told me to, ma'am, like, explain it again. So it's like, okay, I'll do it again. So that's why we are doing it. And moreover, in the previous lecture we didn't discuss it thoroughly. That's why we are doing this. So oxidation number of oxygen, if you say in case of oxides, in case of oxides it is -2. Usually you take the oxidation number of oxide as -2 in case of oxides. And oxides, how do you write oxides? O and 2 negative charge, that's your oxide. So whenever you see oxide, generally its oxidation number is -2. All right. Now let's move further. In case of peroxides, you know already that peroxides are O2 के ऊपर 2 negative charge. Oxide is O के ऊपर 2 negative charge and O2 2 negative. Let's write it this way. It becomes your peroxide. O2 2 negative. This is your peroxide. So in case of peroxides, what happens? See, as you can see here, we have 2 oxygens. And on 2 oxygens, we have -2 charge. So what will be the charge on 1 oxygen? It will be simply -1, you can say. So this is your oxidation number of, oxygen in case of peroxides. Okay. Now, if you talk about the oxidation, I'm not liking the one, I don't know why. So say, let's make it this way. Okay? It is -1. Now, in case of superoxides, what happens is that, now let me first tell you what superoxides are. These are simply O2 के ऊपर -1 charge. O2 के ऊपर -1 charge. 1 minus या 1 -1, you can say anything. Now we know that we have 2 oxygen. And over 2 oxygen, we have 1 negative charge. So on a single oxygen, what will be the charge? It will come out to be -1/2. So in case of superoxides, the oxidation number, or you can just simply say that the oxidation state will be -1/2. Okay. Now, what else? In case of OF2, if you look at OF2, now this becomes like a different case. I'll tell you why. if you talk about OF2, so this will be the structure for fluorine bonds through only a single bond. So we have discussed in the previous slide that the oxidation number of fluorine is -1 always. Wherever you see fluorine, it will be -1, right? Because the fluorine is going to accept electrons. That's why 1 electron and -1, because he will be accepting electrons. So fluorine के ऊपर we already know that it will be -1 charge. -1 charge. And as I have told you, since it is like, you can say, a neutral compound, right? So the overall charge on OF2 should be 0. Overall charge should be 0. So in order to balance these two, -1, -1, that is -2, oxygen will have +2. Oxygen will have +2. So in case of OF2, the oxidation state of oxygen is +2. Similarly, if you draw O2F2, O2F2, then in this case, what will happen? The oxidation state, the oxidation number of O2F2 will be, the oxidation state of oxygen in O2F2 will be how much? It will come out to be simply +1. In the similar manner, if you draw it, we'll find out that this is +1. So these are the various cases of oxygen. Let me see if like you have any doubt till now. Let me check if there is any doubt so that it can be sorted. Okay, no doubt till now. All right. So oxidation number of oxygen is simply, in case of oxides, it is -2. In case of peroxides, it is -1, that is O2, 2 negative. In case of superoxides, it is -1/2. And your superoxides are O2 के ऊपर 1 negative charge. In case of OF2, the oxidation number of oxygen is +2. And in case of O2F2, the oxidation state of oxygen is +1. So I believe that there is no doubt till now in the oxidation state of oxygen, right? No doubt till now. Let's move ahead. Let's move further, okay? Let's move further. So what can we say? What else do we have? So in case of alkali metals, in case of, which number is this? We did number 4. So this will be number 5. So by number 5, if I tell you some fixed what? Oxidation number or oxidation state. So what would it be? So I can say that the alkali metals, that is maybe that's your sodium, your potassium, these are the alkali metals, right? So as we know, these are metals. They will have a tendency to lose electrons, right? In order to gain their octet, correct? So we can say that these alkali metals will always have an oxidation number or oxidation state of +1. Always. Guys, is there any doubt? State of oxidation. Right. So is there any doubt? If yes, then let me know in the live chat or in the comment section. Okay. Now we can move ahead. So for alkali metals, it turns out to be +1 always. Okay. And fluorine is -1 always. So at least remember the one who doesn't have variable oxidation number, so that you can find out the oxidation number of the other as well. Let's talk about the next one. You can say now alkaline earth metals. In case of alkaline earth metals like magnesium, it is what? +2 always. It is +2 always. But if you talk about aluminium, aluminium always have the oxidation number +3. If you talk about aluminium, the oxidation state of aluminium is +3. So remember this. Look at the previous slide as well till now. If you have any doubt in oxidation number, then simply let me know. Okay. So element which exist in free state, उनका oxidation number 0. Atom से simply अगर ion form हुआ है, then oxidation number will be simply the charge on that ion. Then oxidation number of fluorine is -1 always. For oxygen it is variable, I have told you. In case of oxides, that is O2 minus, it will be -2. In case of peroxides, that is O2 2 minus, it will be -1. In case of superoxides, O2 के ऊपर 1 negative charge, it will be -1/2. In case of OF2, since fluorine is more electronegative than oxygen, so in case of OF2, the oxidation number of oxygen will be +2. And in case of O2F2, it will turn out to be +1. Then we did alkali metals के लिए, the oxidation number is always +1. For alkaline earth metals, it is +2. And in case of aluminium, it is +3 always. Always. This happens always. All right. Now, let me tell you one more rule. It will help you throughout. And this rule says that the algebraic sum of the total of the whole species, of the whole compound, will be equal to the total. No, let's not take it this way. I would tell you that let's take an example. It would be pretty easy for us. Let's write that the algebraic sum of the oxidation numbers, if you add all the oxidation numbers of all these species which are present in the compound, the algebraic sum of the oxidation number of all the atoms in a species, it will be equal to what? On the total charge of that molecule. This will be equal to the total charge of the species or that molecule. The total charge on the species. That's what you can say. All right. On that species. For instance, let me give you one example. Let's take H2O. Very simple. Let's take H2O. If I tell you that I don't know what is the oxidation number of hydrogen in this, if I don't know what is the oxidation number or oxidation state of hydrogen in this H2O, so how can you calculate it? Now you know that total charge on this species, the total charge on this molecule of H2O is 0. It is simply what? 0, right? So you can say that since we have 2 hydrogens, we are assuming that the oxidation state of one hydrogen is X. So 2 ka will be 2X. So 2X plus -2 for oxygen, it comes out to be -2, and the total charge of the species is simply 0, right? So if I need to calculate the oxidation number of hydrogen, so this becomes 2x minus 2 is equal to 0. So you can just simply say that 2x is equal to plus 2, and from here x comes out to be 2 by 2, that is 1. Please remember, sometimes what students do is they do 2 by 2 is 0. No, 2 by 2 is 1, right? So here the oxidation state of hydrogen is simply 1. Okay, now let's take another example. If I tell you, say NH3, that is ammonia. If I tell you NH3, and in NH3, say I don't know the oxidation state of nitrogen, but we know that as a whole on this species the charge is 0. So you can say what? Let's take the oxidation number of nitrogen to be x. So it will be x plus, एक हाइड्रोजन का होता है +1, 3 हाइड्रोजन का कितना हो जाएगा? +3. So it will be 3 into 1 plus 1. This comes out to be 0. So x plus 3 is 0. So you can say that x is equal to -3. So from here you can say that the oxidation state or oxidation number of nitrogen is simply -3. Okay. Let me check if you guys have any doubt. Let me check. No doubt till now. Okay. Let me see. We have some time. Cool. Alright. Now, let's discuss some more examples. So this comes out to be x is equal to -3. If we talk about, say, N2O5. If we talk about N2O5. So what can we say? Let's take the oxidation number of nitrogen to be x. So the equation will be 2x plus -2 into 5. That will be -10, and this will come out to be 0 because the whole charge on the species is 0. So it will simply be 2x minus 10 is equal to 0. This will be like 2x is equal to 10, and from here you can say that x is equal to 5. 10 by 2 is simply plus 5. So here the nitrogen is in plus 5. Nitrogen is in plus 5. Okay. So these are the various examples that we did, and you guys know already that if you get the subscription, let me tell you, just give me a moment, right? From here, as you can see here, now you can see properly, right? So you know already the features of Unacademy, that the plus subscription offers you, correct? So these are learning live. As you know that the COVID cases are increasing, so it's like better to stay at home and learn, correct? Then your unlimited access to all the courses, top educators, regular doubt clearing. So there are like various, features of subscription. And as you can see that these are the subscription plans for ICSE boards, and if you apply your YT code here, your code is just show. Yeah, now I can get the why do we landed in this place? Okay, so you can just simply use my code, that is Kirti S Live. My code is what? My code is simply Kirti S Live. Okay, as you can see that it is written here that my code is Kirti S Live. So there are various batches which are going on right now. As you can see, champions for class 9, Param batch for class 10, for class 11, as you can see, I am the chemistry educator. Saurav Verma sir is our biology educator. Sanam sir is our maths educator. So there are various things you can see, you can try, and there is only for today the offer is that you will get 22% off on the code. You will get 22% off, as you can see here. Okay, so I would say to take the plus subscription now, use the code here, that is Kirti S Live. The code is Kirti S Live. So take the subscription now, and we will meet on the plus platform. The class is at 4 p.m. today for class 12. I'll see you guys there. Tab tak ke liye, bye bye and all the best.